Okay, so today we will be deploying a Kubernetes cluster with Kubeadm and Vagrant. So we will be deploying two virtual machines in Vagrant. One will be the control plane and other will be the worker node in Kubernetes. So let us start. Let me bring my terminal. We have split our screen into two. So let us start with the Vagrant version. So I am using the Vagrant version of 2.3.7. We have a Vagrant file in. Let us cat the Vagrant file. So it is a simple Vagrant file with two nodes, with two virtual machines, and we are using the Bento Ubuntu 22.04 as our image. The provider we have set to VirtualBox, and for memory we are keeping it to 2 GB. And for the private network, this is the private IP address that I am setting to. So this is the one that will be the control plane, and this one will be the worker node. Okay, let's kill it now. Let's do a Vagrant up, and this command will install and download all the machines for us. So let us now wait till it is in the running state. So as we can see that our two machines have been ready. Our node A and node B, both of them are ready. Now let us move forward. We'll be using Vagrant status to know the status of both our machines. So as we can see that the current machine status for node 1, it is running on VirtualBox. Node B, it is also running on VirtualBox. So let us move forward, clear the screen. We have these files in our directory. So we will be uploading the VM node A network.network and VM node B .network to our terminal, to our virtual machines. So let us go Vagrant upload, and we will be picking up this file and we will be uploading it to node A. So let us do that. So it has uploaded. The upload has completed successfully. The source was our directory and destination was node 1, node A, and for the node B we will be using Vagrant upload for the node B network, and the destination will be the node B. Let us enter. Okay, the node has been completed successful. It has been uploaded. So at this point we will be splitting our terminal into two terminals. The above terminal will be the node A, and we will be using node A for the control plane, and for the node B we will be using this node B as a worker node. So let us start with the node A. Let us SSH into the node A using the Vagrant SSH node A, and we'll be using the same command for our node B. Let us wait till this command has been successful. Okay, it's successful now. Let us go inside the node B using the Vagrant SSH node B command, and in the node A we will be setting a host name to node A. So for that we will be using this simple command sudo hostnamectl set hostname, and we'll be giving this host node the name of node A. Let's enter this command. Now we will be doing the same command for our node B. We'll be setting a host name for the node B to node B. Enter this command. To verify, let's exit, and then again Vagrant SSH node A. and we'll doing the same thing for node B. Exit, and then SSH node B. So as you can see, Vagrant at the rate node A, and the same will be happening for the node B also. Okay, here it is, Vagrant at the rate node B. Okay, let's clear the screen now. Okay, for the node A, now we have a network file, VM node A network. We will be moving this network file to the HC systemd network. So let me just paste this command here, sudo move the network file here, and we will be moving it to HC systemd network. Let's execute this, and we will be doing the same thing for our node B here, sudo move VM node B network HC systemd network. Okay, it's done. Moving forward, now we will be doing a restart to our systemd network D. For that, the command is sudo systemctl restart systemd network D. We'll execute this command, and we will be doing the same for our node B. Okay, moving forward, now let us ping our node B here from our node A. So in the node A, we will be using ping and the local IP address of our node. So as you can see, it is now, the ping is successful. So let us cancel it. Now let's do the same thing for our node B to ping our node A here with the local IP address of our node A. And as you can see, it is going successfully. Good. Let us clear the screen. So our next step is to install the K8's Kubernetes version, the Kubernetes binary. So for that, we are using the curl command, and we'll be using the same command in both our nodes. Okay, let's check out the version, and as you can see, the Kubernetes version is as of latest 1.28.1. So now we will be installing the Kubeadm, kubelet, and kubectl in both our nodes. For that, we will be using the command sudo curl -l-o user local bin kubeadm. This is where we'll be installing, and this is the binary for our kubeadm. Let's enter it, and the same we'll be doing for the node B. The download has been completed for kubeadm. Now onto the node B, and we'll installing the kubeadm for in this node. After that, we will be installing the kubelet in both our nodes. So as you can see, in the node B, it has completed the download for kubeadm binary. Let's go to the node A, and we'll be downloading the kubelet binary. Again, we'll be installing it in user local bin kubelet. So the kubelet has been downloaded into our user local bin directory, and this we will be using the same command for our node B here. So it has also completed the kubelet download in our user local bin directory in node B. Now let's clear the screen. We have downloaded the kubeadm, the kubelet. Now we are left with the kubectl. So we will be downloading the kubectl binary again in our user local bin directory. So let's enter. So we will be doing the same thing in our node B, downloading the kubectl binary in our user local bin. After the downloading, we will be giving the executable permissions to all three of them, the Kubeadm, kubectl, and the kubelet. So this is the command sudo chmod plus x, the executable permission for our local user bin, and for all three of them cube and star, which means that kubelet, kubectl, and kubeadm that we downloaded. So let us give us the permission. Let's give the same permission for our node B. Now we'll be checking the versions of each of them. First we'll be checking for the kubeadm version. So this is the kubeadm version, which is the 1.28.1. Now let's check the kubelet version. It is also giving us 1.2.28.1. And lastly, let's check the version of kubectl. Okay, so let us now exit to go to our next task. Clear the screen. Okay, now in the node A, as you can see, we have multiple files here. What we have to do is now that we have to upload 3 more files to our node A and 3 files to our node B. The files that we have to upload to node A is the kubeadm node A conf. We have to upload the k8s conf and also the kubelet service. So let's go and upload those files. Vagrant upload kubeadm and kubeadm node a.conf to our node A. Okay, the upload is complete. Now we'll be uploading the k8s.conf to our node A, and lastly we'll be uploading the vagrant upload kubelet service to our node A. Okay, it has been successful. Now let us vagrant SSH into our node A, and let's go to our node B now. For our node B, we will be doing the same thing, but we'll be doing it for our node B. Node B files, upload vagrant upload kubeadm node b.conf to our node B. For the second file, vagrant upload k8s.conf to our node B. And lastly, we'll be doing a vagrant upload kubelet.service for our node B. So now after uploading all these 3 files, we'll be now SSH into the node B, vagrant SSH node B. Now let us clear the screens, and in our node A, we will be creating a directory sudo make directory -p etc systemd system kubelet.service.d. Let us enter, and the file that we uploaded, the kubeadm node a.conf, we will be copying it to our the created directory. Let us copy it into it. Okay, the copy is successful. So also we'll be copying the kubelet.service to etc systemd system directory. Done. Now let us sudo systemctl daemon reload, sudo systemctl -- now kubelet. This will enable it. It created a system link. Now sudo systemctl status kubelet, and this is it is going a failed status, so it is quite normal. Q to quit. Okay, now let us do the same exact things for our node B. For that, sudo make dir -p etc systemd system kubelet.service.d. This is the directory that we want to make. Okay, so now we will be copying the kubeadm node B this time kubelet.conf into the created directory. Let us also copy the sudo cp copy the kubelet.service file into our etc systemd system directory. Now we will be doing a sudo systemctl daemon reload, sudo systems enable -- now kubelet, and sudo systemctl is status kubelet. Again, the status is failed. It is quite normal. Press Q to quit. Clear the screen. Now our next step is to download the container runtime. So what we are doing here is we are curl -l containerd releases download. This is the latest release 1.7.5, and we are downloading for our Linux AMD 64, downloading it to our temp directory as containerd.tar.gz. Okay, so it has downloaded. We will do the same thing for our node B here. So it has completed. Let us now verify the containerd tarball in our /temp directory. So here it is. Also let us do it in node B also. So here it is. Clear the screen. Now we will be downloading a containerd.service file from our from the official repository of containerd in our etc systemd system and containerd.service. So let us download that. We will be doing the same for our node B also. After the download has been complete, now we will be downloading the cryo tarball, the download of the binary download again in our temp directory. So let's do it. We will be doing the same thing for our node B also. So after that, we will be downloading the CNI plugin from the container networking repository, the CNI plugin, and we'll be storing again into the temp directory as cni.tar.gz. We'll be doing the same action in our node B also. Again, is storing it in the temporary repository, in the temporary directory of /temp/cni.tar.gz. Okay, now what we will do is we will be installing all the binaries that we just downloaded. We'll be installing it and pushing it into our respective directories. Let's start with the node A. We'll go into the user local directory, and we will be extracting that the containerd.tar.gz in the temp directory in this directory, which is the local user local. So the extraction has been completed. Let's pop D and come out of that directory. Let's check the containerd by doing a containerd -- version, and it is giving us a 1.7.5. Let's install the CRI-CTL, the cryo-CTL. Let's go into our user local bin and do a sudo tar -xbf from the cryo that we cryo-CTL tarball that we downloaded into our temp directory. Okay, let us come out of that directory and now do a cryo-CTL version. It is giving it a version of 1.28.0. okay, going forward, now let us install the CNI plugins. Let us make a directory that is opt slash cnis dot slash bin, and now go into that directory that we created, and in this directory we will be extracting the tarball of cni.tar.gz. Once it is done, we will be coming out of that. Okay, going on to our node B here. First, again, we will be going over the steps, installing containerd. We will be going to our user local directory, extracting the tarball of containerd. Let's come out of the directory, do a containerd version. Now we will be installing the cryoctl. Let's go to the user local bin, and here we will be extracting the tarball, the cryoctl tarball. Let's come out of that, and let's check the version of cryoctl. Okay, it's giving it 1.28.1, 28.0, sorry. Okay, let's do a installation of CNI plugins. For that, we will be creating directory with -p flag with opt cni/bin, and let's go into that by using pushd. We are inside that directory, and here we will be extracting the tarball of CNI. And once we have done that, we will be going out of that directory. Let's clear the screen again, and this time now we will be configuring the container runtime. For that, we will be updating our repository, the aptitude repository, by doing a sudo apt -y update. We'll be doing the same thing for our node B also. Now let's clear the screen. We will be installing the runc package in both our nodes. Okay, now we will be creating a directory in etc/containerd, and we'll be doing the same thing for our node B also. Going forward, we will be doing a containerd command, which will generate a configuration file, the config default, in our temp/config.toml. Let's do the same thing for our node B also. Now let us cat the toml file that we generated using the containerd command, and it is a very long toml file. Let's also do a cat here in node B. Okay, let's clear our screen. Now let us move this toml file into the directory that we created, which is the etc containerd, by doing a sudo mv/temp/config.toml to our destination, which is the etc containerd. Let's do the same thing for our node B. Okay, now we have to change a line in the toml file, the config toml file, which is we have to activate the systemd C group. Let me show you. We will be grabbing that in the etc containerd config.toml. So we have to make this systemd C group to true. So let us use the sed command, and this sed command is that sudo sed. We will be searching for the system C group, systemd C group. This is the one, and it is now false, and we will be changing this systemd C group to true, and we will do it a global change. And the destination of the file is this, etc containerd config.toml, and after doing that we want to grab the result of the systemd. So let's enter that. Okay, so it has changed it to true, but still this change is temporary. Let me show you why I'm telling you that. Uh, so it is still false in the original file, so we haven't changed it permanently. So to do that we will be using the same command, but but now we'll be doing the I flag. We will be doing a set I flag, and we will be doing it permanently. Okay, now also grab and verify that the config.toml file has actually changed, and as you can see, systemd C group is turned to true now, and this is the original file. Okay, now let's go to our node B and do the same steps here also. We have moved the file to our etc containerd. Let's grab it. Systemd C group is false. Okay, again we will be changing it, but again this change is not permanent. To We can verify it that is not permanent in our original file. To make it permanent, we'll be using the -I flag. Okay, so let's verify that the changes has been applied in the original file, and the changes has been permanent. Yes, the systemd C group has turned to true. Let's clear our terminals. Now at this stage we will be starting the container runtime. So let's go and start with the node A. We'll be doing a sudo systemctl daemon reload. We'll be doing a systemctl enable now containerd, and sudo systemctl status containerd, which it comes to an active. Okay, let's press Q for quit. We will be doing the same thing for our node B also. Sudo systemctl daemon reload, sudo systemctl enable -- now containerd, and sudo systemctl status containerd, and also it is giving us an active status. Let's clear the screen. Let us now test the containerd that it is actually working. For that we will be using a sudo ctr image pull docker.io/library/hello world, and we'll be using a latest tag to it. So it has downloaded it. Let's do the same thing for our node B also. Okay, so now we will be starting our container, and for that we will be using the command sudo ctr run --rm docker.io library hello world latest and test. Okay, so hello from Docker. So this means that our installation is appear to be working correctly. Okay, let's do the same thing for our node B also. It is also working correctly. Now let's clear our screen and go to the next step. Now we will be enabling the networking features in our nodes. We'll be doing a sudo kubeadm reset -f. We will be installing two packages. One is socat and the other is contract. Okay, it has completed the download. We will be turning off the swap, sudo swap off -a, and sudo systemctl mask swap.img.swap. Let us now create a k8s.conf file by using a sudo touch etc modules.load.d k8s.conf etc system sysctl.d slash k8s.conf, and now we will be editing that using vim I to insert, and we will be just adding two lines here. One is overlay and the second is br underscore net filters. Let's get out of it by pressing escape :wq. Another file in the etc system ctl that we created just above, and now we created the file. Now we'll be editing the file in I to insert, and here we will be we have three lines: net bridge dot bridge and nf call ip table equals to 1, net bridge nfs call ip6 tables equals to 1, and net dot ipv4 ip forward equals to 1. Again, escape to come out of it, :wq to save and quit, and we will be doing a reboot here. But before that, let's go and do the same things for our node B also. We will be doing installation of socat and contract. We will be turning off the swap. Again, creating files for our k8s conf, editing the first file via vim, press I to insert, we'll be adding overlay and br net filters, escape :wq, editing the second file. In this file, I to insert, okay, pasted here, :wq. Now let us reboot both of our nodes by doing a sudo reboot. Also here sudo reboot. Now let us come back after 5 minutes or so. Okay, so we are inside the Vagrant SSH node A, and we did the same thing with the node B also. Let's go forward from that. Now we will be starting. Now we will be starting the control plane on the primary node by using a sudo kubeadm init phase preflight. Okay, so it has pulled the image. Now for the second command, we will be doing a sudo kubeadm init --api server -advertise -address, the address for our node A, and the pod network CIDR, which is we have set to 164.0/0/16. So this is the command that generates a lot of things. So let's go over generating the CA certificate key, certificate N key, API server certificate N key. We can see that it is generating the API server kubelet client. We can see that it is generating the HCD server, HCD pair. We can also see that it is generating the kubeconfig folder, the admin config, the kubelet config, and the controller manager config, the scheduler config. So this commands does a lot of things. Now it is also starting the kubelet and the RBAC rules, and it has also in the end it has also given us a command for the Kubeadm join for our other node to join to this cluster. So we will be using this command later on, but first let us do a kubectl /-- kubeconfig, and we can see that the control plane is still not ready, and what we will do is that the next step is to install Enthria as our network policy. So this is the command where we will be sudo kubectl -- kubeconfig etc kubernetes admin.conf. We will be applying -f the http github.com enthria.io. Enthria releases downloads 1.3.0 is the version, enthria.yaml. So it has created a bunch of resources for us, the custom resource definitions, the service account, secrets, config map, cluster role, RBAC rules, the cluster role bindings, service, daemon set, deployment, API service. Let's again do a kubectl -- kubeconfig etc kubernetes admin conf, and to get nodes, and still it is not ready, so we will wait till the this node control plane is in the ready status. Try this command sudo kubectl config kubeconfig and to get nodes, and it is the control plane is in the ready state. We will be joining the worker node to the primary node, and for that we will be copying this command and in our node B, which is in the worker node, we will be pasting here. Okay, it is saying that we have to use the sudo. Okay, so the node has joined our worker node. So again, let us go and do a kubectl get nodes, and here we will be seeing that node B has joined the cluster, but still it is not ready. So let us give it some time to go into ready state also. Okay, let us now again do a kubectl get nodes, and this time we can see that our node B is also ready. So the last step is to test the cluster with an example app. For that we will be executing this command kubectl kubeconfig etc kubernetes admin conf run --rm --standard in --image. We will be using the hello world image of Docker, and --restart to never, and request timeout is 30, and we are giving it a name of test pod. Let's execute this. Okay, as we can see that we are getting a message of hello from Docker. So this means that our cluster is working properly. Okay, I think that's pretty much it now. To clean up, we will be doing an exit into both our nodes, and then let's clear, and well, now we will doing a vagrant destroy, and we will be doing a yes on all the prompts that it gives us. Okay, so I think that's pretty much it. Thank you for watching. Bye.